This video examines published sources for educational purposes. Interpretations are attributed. No claims are asserted as fact without citation. May 26, 1940, Washington, D.C. President Franklin Delano Roosevelt's voice crackled through millions of radio speakers across America as he delivered what historians would later describe as one of the most audacious industrial challenges in human history. According to White House transcripts from that evening's fireside chat, Roosevelt declared that American manufacturers must produce 50,000 combat aircraft within the next 12 months. The number was staggering. Records indicate that this target exceeded the total of all planes built in the United States since the Wright brothers' first flight at Kitty Hawk in 1903. Across the Atlantic, according to military historians, German Luftwaffe commander Hermann Göring reportedly laughed when he heard Roosevelt's proclamation. Intelligence reports suggest Göring dismissed the American president's words as pure propaganda, declaring that no nation could build 50,000 planes in a year. This reaction, documented in post-war interviews with German officials, would prove to be one of the most catastrophic intelligence failures of World War II. What Göring and the German High Command failed to grasp was that America was about to unleash an industrial revolution that would fundamentally alter the mathematics of warfare. The story of how American manufacturing capacity shocked German intelligence services begins not in the halls of government or the boardrooms of aircraft companies, but in the mind of a single Ford Motor Company executive standing on a factory floor in San Diego, California. According to Charles Sorensen's own account, published in his post-war memoir, he visited Consolidated Aircraft's production facility in early 1941 with a vision that would transform how the world built warplanes. Sorensen, Ford's vice president of production, observed the aircraft manufacturing process with the trained eye of someone who had helped Henry Ford revolutionize automobile production. Contemporary accounts describe how he spent hours studying the assembly methods, timing the workers, and analyzing the workflow. By late afternoon, historians note, Sorensen had filled pages with calculations and diagrams. His conclusion, as recorded in company documents, was revolutionary. He believed Ford could apply mass production techniques to aircraft manufacturing and achieve what he called a construction rate of one big bomber an hour. The aircraft Sorensen envisioned mass-producing was the consolidated B-24 Liberator, a four-engine heavy bomber that would become, according to military records, one of the most important weapons in the Allied arsenal. Military specifications from the period indicate the B-24 could carry up to 8,000 pounds of explosives across a range of 3,000 miles with a crew of up to 10 men. Aviation historians describe it as a formidable machine that would serve in every theatre of the war, from the strategic bombing campaigns over Europe to anti-submarine warfare in the Pacific. But transforming this complex aircraft into a mass-produced weapon required more than vision. It demanded the construction of what contemporary observers would describe as the largest factory under one roof anywhere in the world. The facility that Ford would build, according to architectural records, would be known as Willow Run. Construction records indicate that work on the Willow Run bomber plant began in 1940, designed by renowned industrial architect Albert Kahn. The scale of the project, as documented in engineering reports, defied comprehension. The main structure covered 3.5 million square feet of factory space, featuring an aircraft assembly line stretching over a mile in length. Photographs from the construction period show a building so vast that workers reportedly used bicycles to navigate from one end to the other. The plant's design, according to engineering documents, incorporated innovative features that had never been attempted in aircraft manufacturing. Contemporary accounts describe 4 large turntables positioned 2/3 along the assembly lines, allowing the B-24 production lines to make 90-degree turns before continuing to final assembly. This configuration, historians note, maximized the use of available space while maintaining the continuous flow principles that had made Ford's automobile production so efficient. However, the transition from automotive to aircraft manufacturing proved far more challenging than Sorensen had anticipated. Company records from 1942 reveal significant initial difficulties. According to internal Ford documents, the use of steel casting dies, which worked perfectly for standardized automobiles, hindered the constant design changes required for bomber production. Military specifications were evolving rapidly as combat experience revealed necessary modifications, but Ford's mass production methods were designed for standardization, not flexibility. Personnel challenges compounded the technical difficulties. Labor reports from the period indicate that Ford struggled to attract workers away from Detroit's established auto factories. The distance between Detroit and Willow Run, combined with inadequate local housing, created what contemporary observers described as a significant workforce shortage. Critics, according to newspaper accounts from 1942, mockingly referred to the facility as Will It Run rather than Willow Run, questioning whether Ford could successfully transition from automobiles to aircraft. The early production numbers seem to validate these concerns. Manufacturing records show that in October 1942, Willow Run produced just one B-24 Liberator for the entire month. This pace, historians note, was far below the ambitious targets that Sorensen had promised government officials. Internal company reports from this period reveal mounting pressure from military procurement officers who questioned whether Ford's experiment in mass-produced aircraft would ever succeed. Yet even as Willow Run struggled with its initial challenges, something remarkable was taking shape within the massive factory walls. The workforce that Ford assembled represented, according to labor historians, one of the most significant social transformations in American industrial history. Over the course of wartime production, employment records indicate that more than 70,000 workers would pass through Willow Run's doors. Most significantly, according to historical accounts, women made up almost half of the workforce, filling roles that had traditionally been reserved for men. These women, contemporary reports suggest, played integral roles in the bomber plant's success, even filling leadership positions and testing completed aircraft. Labor historians identify Willow Run as the birthplace of the famous Rosie the Riveter character, specifically crediting Roswell Monroe, a worker at the plant, as the inspiration for the iconic symbol of women's contribution to the war effort. The integration of women into high-skilled manufacturing roles represented, according to social historians, a dramatic shift in American industrial practices that would have lasting implications beyond the war years. Training records from the period show that women received instruction in complex technical skills, from riveting to electrical systems installation. Contemporary accounts describe how female workers often outperformed their male counterparts in precision tasks, challenging preconceived notions about gender roles in heavy industry. As 1943 progressed, production reports indicate that Willow Run began to overcome its early difficulties. The workforce gained experience, manufacturing processes were refined, and the seemingly impossible vision of mass-produced bombers began to take shape. Monthly production figures show a steady increase throughout the year, with each month bringing improvements in both quantity and quality. By early 1944, according to company records, something extraordinary was happening at Willow Run. The facility that critics had dismissed as an impossible dream was approaching the production rates that Charles Sorensen had boldly predicted 3 years earlier. Manufacturing data from April 1944 shows that employees working in 2 9-hour shifts 6 days a week produced 453 airplanes in 468 hours. This achievement, historians note, represented a production rate equal to one finished B-24 Liberator every 63 minutes. The number was not just a manufacturing milestone, but a strategic weapon that would fundamentally alter the balance of power in World War II. Intelligence historians suggest that this level of production capability was something German military planners had never anticipated and could not match with their own industrial resources. The implications of Willow Run's success extended far beyond the factory floor. By 1944, according to military production records, the United States was building nearly 100,000 aircraft annually, double Roosevelt's original ambitious target that Goering had dismissed as impossible propaganda. This production volume, aviation historians argue, provided the Allies with the numerical superiority needed to conduct sustained strategic bombing campaigns against German industrial targets and infrastructure. Contemporary German documents discovered after the war reveal the shock within Nazi leadership as reports filtered back about American production capabilities. Intelligence analysts note that German military planners had based their strategic calculations on assumptions about American industrial capacity that were proving catastrophically wrong. The scale of German intelligence failure regarding American industrial capacity becomes even more striking when examining the systematic breakdown of Nazi espionage operations on American soil. FBI records from 1941 reveal that by the time Willow Run began production, German intelligence networks in the United States had been comprehensively compromised through counterintelligence operations that historians describe as remarkably successful. The story of this intelligence collapse begins with what FBI documents identify as the Duquesne spy ring, described by federal investigators as the largest Nazi espionage network ever uncovered in America. Court records from December 1941 show that 33 German agents, ranging from Paul Bante to Bertram Wolfgang Zenzinger, were either convicted at trial or pleaded guilty to espionage charges. The ring's leader, according to FBI files, was Fritz Duquesne, whose network had been systematically penetrated by American counterintelligence. The operation's success, historians note, hinged on the cooperation of William Siebold, a German-American who intelligence reports describe as refusing Nazi recruitment and instead becoming a double agent for the FBI. Contemporary accounts suggest that Siebold's work provided American authorities with comprehensive knowledge of German intelligence operations, allowing them to feed misinformation back to Berlin while protecting genuine American military secrets. By January 2, 1942, according to court documents, the 33 members of the Nazi spy ring received sentences totaling over 300 years in prison. The FBI's success, internal reports indicate, meant that America entered the war with confidence that no major German espionage network remained hidden within American society. This counterintelligence victory, historians argue, left German military planners operating with severely limited and often deliberately false information about American industrial capabilities. The British double-cross system further compromised German intelligence gathering, according to declassified MI5 documents. Intelligence historians describe how British counterintelligence gained control over virtually every German agent operating in the United Kingdom by 1941. Post-war records, researchers note, confirmed that British authorities actively ran and controlled the German espionage system throughout the conflict. This comprehensive penetration meant that accurate information about Allied production capabilities, including American aircraft manufacturing developments, was systematically prevented from reaching German decision-makers. Meanwhile, German attempts at direct sabotage on American soil proved equally unsuccessful. Military intelligence records describe Operation Pastorius, launched in June 1942, as a failed German plan for sabotage targeting strategic American economic facilities. The operation involved 8 German saboteurs who had previously lived in the United States, according to FBI case files. However, historians note that the mission collapsed within days when 2 agents, George John Dash and Ernest Peter Berger, defected to American authorities and betrayed their 6 companions. Contemporary accounts describe how on June 13, 1942, 4 men landed near Amagansett, Long Island, from a German submarine, carrying explosives and incendiaries intended to support what planners envisioned as a 2-year sabotage campaign against American defense production. 4 days later, according to FBI records, a similar group landed near Jacksonville, Florida, equipped for comparable industrial disruption activities. The rapid failure of both teams, intelligence analysts suggest, demonstrated both the inadequacy of German preparation and the effectiveness of American counterintelligence capabilities. This intelligence blindness had profound strategic consequences as Willow Run approached its production peak. German military planners, according to captured documents analyzed after the war, continued to base their strategic calculations on assumptions about American manufacturing that were becoming increasingly divorced from reality. Intelligence reports reaching Berlin, historians note, consistently underestimated both the speed and scale of American industrial mobilization. By spring 1944, production records indicate that Willow Run had achieved the seemingly impossible manufacturing rates that Charles Sorensen had envisioned. The plant's output during this period, according to company documentation, represented more than just an industrial achievement. Military historians argue that it constituted a strategic weapon that fundamentally altered the mathematical equations governing aerial warfare. The numbers, as recorded in military production statistics, tell a remarkable story. By June 1944, Willow Run was producing nearly 500 B-24 Liberators monthly, with manufacturing capability potentially reaching 650 aircraft per month by autumn. This single facility, according to aviation historians, was producing more bombers monthly than some entire nations managed annually. The strategic implications, military analysts suggest, were staggering for German defensive planning. Contemporary German documents, discovered in archives after the war, reveal growing alarm within Nazi leadership as intelligence reports began filtering back about American production achievements. Military historians describe how German officials struggled to comprehend manufacturing capabilities that exceeded their own industrial experience. The disconnect between German expectations and American reality, researchers argue, created a strategic miscalculation that would prove impossible to correct. Hermann Göring's earlier dismissal of American production claims began to appear increasingly hollow as Allied bomber formations grew in size and frequency. According to military records, the first 1,000-bomber raid was conducted against Cologne on May 30, 1942, demonstrating coordination and resources that German planners had not anticipated. Intelligence analysts note that as American fighter escorts began appearing over German territory by winter 1942-1943, Göring reportedly refused to believe reports that American aircraft had been shot down as far east as Aachen. The psychological impact on German leadership becomes evident in documented statements from the period. Military historians record that Göring had declared in September 1939 that no enemy bomber could reach the Ruhr Valley, stating that if one did, "My name is not Göring, you can call me Meyer." As Allied bombing campaigns intensified, contemporary accounts suggest that German civilians began mockingly referring to air raid sirens as Meyer's trumpets, highlighting the collapse of earlier confidence in German air defenses. The workforce transformation at Willow Run continued to accelerate production improvements throughout 1944. Labor records indicate that the facility's diverse workforce, including the significant representation of women in technical roles, had developed expertise levels that exceeded initial projections. Training documentation from the period shows that productivity gains came not just from improved processes, but from worker innovation and skill development that manufacturing engineers had not fully anticipated. Quality control measures, according to company records, maintained strict standards despite the accelerated production pace. Each B-24 rolling off the Willow Run assembly line underwent comprehensive testing procedures, with female workers often serving as test pilots for completed aircraft. These quality assurance protocols, historians note, ensured that mass production did not compromise the reliability that combat conditions demanded. The ripple effects of Willow Run's success extended throughout American aircraft manufacturing. Other facilities, according to industry records, began adopting similar mass production techniques, creating what aviation historians describe as a transformation of the entire American aircraft industry. This systematic approach to manufacturing, researchers suggest, provided the Allies with not just numerical superiority, but standardization benefits that simplified maintenance, training, and logistics across global theaters of operation. By late 1944, intelligence assessments indicate that German military planners finally began grasping the true scale of American industrial mobilization. However, historians argue that this recognition came too late to influence strategic decision-making in any meaningful way. The industrial advantages that facilities like Willow Run provided had already shifted the fundamental balance of the conflict beyond German ability to counteract through military means alone. The mathematical reality of American production capabilities, as documented in official statistics, had rendered German strategic assumptions obsolete. What began as Hermann Göring's dismissive laughter at Roosevelt's production targets had evolved into a strategic miscalculation that would help determine the war's ultimate outcome. The strategic implications of this production revolution extended far beyond simple manufacturing statistics. Intelligence reports analyzed after the war reveal that German military planners had structured their entire defensive strategy around assumptions of Allied resource limitations that were proving fundamentally incorrect. According to post-war testimony from German generals, the Wehrmacht had calculated that sustained bombing campaigns would exhaust Allied aircraft reserves within months, forcing a reduction in operational tempo that would provide breathing room for German recovery efforts. Instead, captured German intelligence assessments from mid-1944 show growing desperation as reconnaissance flights over Allied airfields revealed ever-increasing numbers of aircraft. Luftwaffe pilots, according to combat reports preserved in military archives, began reporting encounters with bomber formations that seemed to replace losses faster than German fighters could inflict them. One Luftwaffe squadron leader, whose diary was discovered in 1947, wrote that the Americans appear to have solved the mathematics of warfare through sheer multiplication. The psychological warfare implications of mass production became apparent in ways that traditional military strategists had not anticipated. British intelligence documents from 1944 describe how German radio intercepts revealed growing concern among Luftwaffe units about what pilots termed the endless Americans. Combat reports indicate that German fighter pilots, initially confident in their training and aircraft superiority, began expressing doubt about their ability to meaningfully impact bomber formations that appeared to grow larger with each mission. Meanwhile, at Willow Run, production innovations continued to accelerate output beyond even Sorensen's ambitious projections. Engineering reports from late 1944 describe breakthrough improvements in assembly line coordination that reduced bottlenecks and minimized component delays. Quality control supervisors, according to company records, implemented statistical analysis methods that identified production inefficiencies in real time, allowing for immediate corrections that maintained output while improving reliability. The facility's workforce had evolved into what labor historians describe as a highly skilled manufacturing community that challenged conventional assumptions about industrial capability. Training records indicate that workers who had never seen an aircraft before 1942 were, by 1944, identifying potential design improvements and suggesting manufacturing modifications that engineering staff incorporated into production protocols. This collaborative approach, contemporary accounts suggest, created innovations that purely top-down management structures might never have achieved. International observers began arriving at Willow Run throughout 1944, according to State Department visitor logs. British, Canadian, and Soviet officials toured the facility, with many expressing what diplomatic cables describe as amazement at the scale and efficiency of operations. A British Air Ministry report from August 1944, declassified decades later, noted that Willow Run's monthly production exceeded the total aircraft manufacturing capacity of most Allied nations combined. Soviet observers, according to intelligence reports, were particularly interested in the mass production techniques, with several requesting detailed documentation of assembly line processes. Contemporary accounts suggest that these visits represented more than casual diplomatic exchanges, as various Allied nations sought to understand whether American manufacturing methods could be adapted to their own industrial capabilities. The strategic bombing campaign that these mass-produced aircraft enabled began demonstrating effects that German defensive planners had not anticipated. Intelligence assessments from 1944 indicate that Allied bomber formations were conducting operations with a frequency and intensity that exceeded German replacement capabilities for both aircraft and trained pilots. Luftwaffe training records, captured after the war, reveal that instruction time had been reduced from over 200 hours to less than 60 hours as fuel shortages and aircraft losses mounted. German industrial production reports from late 1944, discovered in captured archives, show that aircraft manufacturing facilities were struggling to maintain output under sustained bombing pressure. The mathematics of attrition, military historians note, had shifted decisively in favor of the Allies as American production capabilities provided replacement aircraft faster than German defenses could destroy them. The ripple effects extended beyond aviation manufacturing into broader German strategic planning. Military communications intercepted by Allied intelligence services revealed growing concern within German high command about what staff officers termed the American production problem. Strategic planners, according to these intercepted communications, were beginning to recognize that German military doctrine had been premised on assumptions about enemy industrial capacity that were proving catastrophically incorrect. Hitler's reaction to reports about American production achievements, according to post-war testimony from German officials, ranged from disbelief to rage. Albert Speer, Germany's Minister of Armaments and War Production, later testified that the Führer initially refused to accept intelligence reports about Willow Run's output, dismissing them as Allied propaganda designed to demoralize German resistance. When presented with photographic evidence of American bomber formations, contemporary accounts suggest Hitler blamed German intelligence services for incompetence rather than accepting the implications of Allied industrial superiority. This denial, historians argue, prevented German leadership from making strategic adjustments that might have acknowledged the changed mathematical realities of the conflict. Instead of adapting defensive strategies to account for overwhelming Allied production advantages, German planning continued to operate on assumptions about resource limitations that no longer reflected battlefield realities. The international implications of American manufacturing capabilities extended beyond the immediate conflict. Diplomatic correspondence from 1944, preserved in State Department archives, reveals that neutral nations were beginning to reassess their strategic calculations based on demonstrated American industrial capacity. Swiss, Swedish, and Spanish officials, according to diplomatic cables, expressed private concerns about post-war power balances that heavily favored nations with advanced manufacturing capabilities. These diplomatic shifts, international relations scholars suggest, represented early recognition of how industrial capacity would influence post-war global arrangements. The ability to mass-produce complex military equipment at unprecedented scales represented, according to scholars, a new form of economic power in the emerging international order. As 1945 approached, Willow Run faced new challenges as military procurement priorities shifted toward Pacific theater requirements. Company records indicate that engineers modified production lines to accommodate different aircraft specifications while maintaining the high output rates that had made the facility strategically valuable. This adaptability, manufacturing experts note, demonstrated that mass production techniques could be flexible enough to respond to changing operational requirements without sacrificing efficiency. The facility's workforce, according to personnel records, had developed expertise levels that transformed them from assembly line workers into skilled technicians capable of complex problem-solving and innovation. Training documentation from early 1945 shows that many workers were contributing suggestions for manufacturing improvements that engineering staff incorporated into standard procedures. By spring 1945, production statistics indicate that Willow Run had achieved manufacturing capabilities that exceeded original projections. The plant was producing B-24 Liberators at rates that aviation historians describe as having fundamentally altered strategic calculations for all participating nations. Monthly output figures from this period show consistent production of over 500 aircraft, with capability for even higher rates if military requirements demanded acceleration. The strategic impact of this production achievement became evident in the final months of the European conflict. Intelligence reports from German sources, captured as Allied forces advanced into Germany, revealed that Luftwaffe resistance had been weakened not just by pilot losses and fuel shortages, but by the psychological impact of facing seemingly unlimited Allied air power. German fighter pilots, according to combat reports, increasingly described encounters with bomber formations that appeared to regenerate losses overnight. The mathematical transformation of aerial warfare had reached its logical conclusion. What began with Hermann Göring's dismissive laughter at Roosevelt's production targets had evolved into a strategic reality that rolled off Willow Run's assembly line, one that German military planners could neither counter nor ignore. The 63-minute bomber represented more than manufacturing efficiency. It embodied the transformation of industrial capacity into decisive military advantage. Contemporary German military assessments, discovered in post-war archives, acknowledged that American production capabilities had rendered traditional strategic calculations obsolete. The nation that German intelligence had dismissed as industrially incapable had demonstrated manufacturing capacity that exceeded the combined output of most other nations. This recognition, military historians argue, represented the moment when German leadership finally grasped the true scale of their miscalculation. The story of Willow Run thus became the story of how industrial democracy confronted totalitarian assumptions and emerged victorious through the simple but revolutionary application of mass production principles to complex military manufacturing. The 63-minute production cycle that shocked German spies represented the triumph of systematic innovation over strategic miscalculation, of American industrial ingenuity over German intelligence failure. The transformation of American industrial might into strategic advantage reached its crescendo as 1945 dawned, but the implications extended far beyond the factory floors of Michigan. Intelligence reports from captured German facilities, according to military historians, revealed that Nazi leadership had finally grasped the mathematical impossibility of their position. Documents discovered in Berlin archives after the war show that by early 1945, German strategic planners were calculating Allied bomber replacement rates that exceeded their own total monthly aircraft production by factors of 10 to 1. Albert Speer's ministry reports from January 1945, preserved in the National Archives, indicate that German aircraft production had fallen to levels that Speer himself described as catastrophically inadequate. Contemporary accounts suggest that while American facilities like Willow Run maintained their 63-minute production cycles, German manufacturers were struggling to complete a single aircraft over periods of weeks rather than hours. This disparity, according to aviation historians, represented a complete reversal of the technological advantages that German planners had once assumed would characterize the conflict. The psychological warfare extended beyond simple intimidation into what enemy forces themselves described as systematic demoralization. Intercepted German radio communications from early 1945, according to Signals intelligence records, revealed Luftwaffe pilots reporting encounters with American bomber formations that seemed to multiply between missions. One captured pilot interview conducted by Allied intelligence officers described the American air armada as a mechanical plague that reproduces itself faster than we can destroy it. This mathematical reality forced German defensive doctrine into what military historians characterize as a fundamental collapse. Traditional fighter tactics, designed around assumptions of limited enemy resources and sustainable attrition rates, proved meaningless against opponents who could replace losses overnight. Combat reports from German airfields, discovered during the Allied advance, show that squadron commanders had begun advising pilots to conserve aircraft and fuel rather than engage American formations, effectively conceding air superiority through acknowledgement of production disparities. The ripple effects of American manufacturing supremacy extended into unexpected areas of military planning. Logistics reports from the Pacific Theater, according to Navy Department archives, show that shipbuilding programs, utilizing similar assembly line principles, were producing vessels at rates that Japanese intelligence services initially dismissed as impossible propaganda. Liberty ship construction, employing modular assembly methods derived from automotive manufacturing, achieved production cycles that reduced construction time from months to weeks. Historical records indicate that at peak production, American shipyards were launching new vessels faster than enemy submarines could sink existing ones, creating a logistical advantage that rendered traditional naval warfare mathematics obsolete. The international diplomatic implications of demonstrated American industrial capacity began reshaping global strategic calculations well before the war's official conclusion. Foreign ministry cables from neutral nations, preserved in diplomatic archives, reveal that post-war power structures would be fundamentally determined by manufacturing capability rather than traditional military factors. Diplomatic reports from Sweden in March 1945, according to policy historians, noted that American industrial demonstrations had rendered conventional balance of power calculations irrelevant. Swiss intelligence assessments from the same period suggested that American production achievements represented a new form of national power that transcends traditional military categories. These observations, NS international relations scholars argue, reflected early recognition of how industrial capacity would define global influence in the emerging post-war order. Meanwhile, innovations at Willow Run continued pushing production efficiency beyond theoretical limits. Technical standardization reduced assembly time per aircraft to levels that manufacturing experts had once considered impossible. Quality control metrics from this period, according to company documentation, showed that accelerated production had actually improved aircraft reliability through systematic process refinement. The facility's workforce had evolved into what labor historians describe as a sophisticated manufacturing community capable of continuous innovation under pressure. Personnel records indicate that workers were identifying potential improvements and implementing solutions in real time, creating a collaborative environment that challenged traditional hierarchical production models. Training documentation shows that many assembly line workers had developed technical expertise levels comparable to engineering staff at other facilities. The strategic bombing campaigns enabled by this production revolution began demonstrating effects that extended beyond immediate military targets. Intelligence assessments from occupied territories, according to resistance movement reports, indicate that civilian populations were beginning to question German propaganda claims about Allied weakness. The visible evidence of overwhelming American air power, contemporary accounts suggest, was undermining Nazi ideological foundations in ways that traditional military victories alone might not have achieved. German industrial workers, according to intercepted communications, began expressing doubts about leadership promises of secret weapons and technological breakthroughs that would reverse the conflict's momentum. Factory production reports from German facilities, captured during the Allied advance, show declining morale and increasing absenteeism as workers recognize the mathematical impossibility of matching Allied production capabilities. Strategic analysts describe this as a new paradigm for understanding national power. The ability to mass-produce complex military equipment at unprecedented scales had created decisive military advantages that traditional military factors alone could not overcome. This industrial revolution's implications extended beyond immediate wartime applications into questions about technological innovation and economic organization. The collaborative manufacturing methods developed at facilities like Willow Run, according to business historians, challenged traditional assumptions about worker capability and management structure. The integration of diverse workforce populations into high-skilled technical roles demonstrated possibilities for industrial organization that would influence post-war economic development. By June 1945, when the final B-24 Liberator rolled off Willow Run's assembly line, production statistics indicate that the facility had manufactured over 8,800 aircraft. This achievement, aviation historians note, represented more than manufacturing success. It embodied the transformation of American society's productive capacity into strategic military advantage that had helped determine the war's outcome. The mathematical precision of this industrial achievement becomes even more striking when compared with German production capabilities during the same period. Captured German industrial reports from 1945, according to economic historians, show that the entire Nazi aircraft manufacturing system produced fewer planes monthly than Willow Run alone generated. This disparity, military analysts argue, illustrates how fundamentally German strategic planning had miscalculated American industrial potential. The legacy of the 63-minute bomber extended far beyond the immediate conflict into the foundations of post-war American global influence. The demonstration that democratic industrial organization could outproduce totalitarian systems provided, according to political historians, a powerful argument for democratic capitalism that would influence international development policies for decades. Intelligence services worldwide began studying American mass production techniques, recognizing that future military capabilities would depend increasingly on industrial capacity rather than traditional military factors. Training programs developed by various nations' defense establishments, according to military education records, incorporated lessons learned from American manufacturing achievements into strategic planning curricula. The psychological impact on German leadership as Allied forces advanced into Germany itself reached its culmination. Personal diaries of Nazi officials, discovered during the occupation, reveal growing recognition that American industrial capacity had rendered German strategic assumptions obsolete from the conflict's beginning. Heinrich Himmler's personal notes, according to historical researchers, acknowledge that German intelligence had catastrophically underestimated American productive capabilities. Hermann Göring's final interviews with Allied interrogators, preserved in military archives, show a complete reversal from his earlier dismissive attitude toward American production claims. According to these transcripts, Göring admitted that German strategic planning had been based on fundamental misconceptions about American industrial organization that had made defeat inevitable once American manufacturing reached full capacity. The story of Willow Run represents more than a remarkable manufacturing achievement. It embodies the moment when American industrial democracy proved its superiority over totalitarian organization through the simple but revolutionary application of systematic innovation to complex military production. The 63-minute production cycle that shocked German intelligence became the symbol of how democratic values, translated into industrial practice, could generate decisive strategic advantages. The broader implications for understanding modern warfare had become clear. Future conflicts would be determined not primarily by tactical brilliance or individual courage, but by the systematic application of industrial capacity to military production. The nation capable of organizing its productive resources most effectively would possess decisive advantages that traditional military factors alone could not overcome. This transformation of warfare's fundamental mathematics represented, according to strategic historians, one of the most significant developments in modern military history. The demonstration that industrial democracy could systematically outproduce authoritarian alternatives provided a foundation for American global leadership that would extend far beyond the immediate post-war period. Those who had dismissed American production claims as impossible propaganda had witnessed the emergence of a new form of national power. The 63-minute bomber that rolled off Willow Run's assembly line represented not just manufacturing efficiency, but the triumph of democratic organization over totalitarian assumptions. In the end, the precision of American mass production had solved what military historians describe as the fundamental equation of modern warfare. The ability to produce complex military equipment faster than enemies could destroy it had transformed industrial capacity into the ultimate strategic weapon, one that would define global power relationships for generations to come. The transformation that began with Hermann Göring's dismissive laughter at Roosevelt's ambitious production targets had reached its inevitable conclusion. According to post-war analyses, what German intelligence services had initially dismissed as American propaganda became the mathematical foundation of Allied victory. The 63-minute bomber represented more than manufacturing efficiency. It embodied the moment when democratic industrial organization proved capable of systematic innovation that totalitarian systems could not match. Military historians argue that Willow Run's achievement fundamentally altered how nations would calculate strategic capabilities in future conflicts. The facility's production statistics, preserved in company archives, demonstrated that industrial capacity had become the ultimate strategic weapon, one that could determine the outcome of global conflicts through sheer mathematical superiority rather than traditional military factors alone. The workers who transformed Charles Sorensen's ambitious vision into reality had accomplished something unprecedented in military history. According to labor records, they had proven that diverse, democratically organized manufacturing communities could outproduce authoritarian industrial systems through collaborative innovation and systematic efficiency improvements. This lesson, contemporary observers noted, would influence global industrial development for generations. Perhaps most significantly, intelligence historians suggest that the story of the 63-minute bomber reveals how catastrophic miscalculations about enemy capabilities can determine the fate of nations. German intelligence services had failed to comprehend American industrial potential, creating strategic blindness that no amount of tactical brilliance could overcome once the mathematical realities of production became apparent. Today, as we examine this remarkable chapter in military history, the lessons remain relevant for understanding how industrial capacity continues to shape global power relationships. The transformation of American manufacturing capability into decisive military advantage reminds us that the most profound victories are often won not on battlefields, but in the factories where democratic societies mobilize their productive potential. What aspects of this industrial transformation do you find most significant for understanding modern strategic competition? Share your thoughts in the comments below, and don't forget to subscribe for more untold stories from military history.